Welcome to this introduction to exam topic 6. My name's Andy Wicks, and in this particular programme we'll be looking at working with methods and encapsulation. Let's start with the exam objectives. The first objective is to create methods with arguments and return values. The second objective is to apply the static keyword to methods and fields. Then we move on to create overloaded methods. Next, we're going to differentiate between default and user-defined constructors. Then it's on to access modifiers and applying encapsulation principles to a class. And finally, we're going to look at determining the effect upon object references and primitive values when they're passed into methods that change the values. Let's get to the first item. Create methods with arguments and return values. All methods must have a return type, even if that return type is void. If a method has a return type that's not void, then it must have at least one return statement. So if it's of type integer or string, you've got to have a return statement. The type of the variable in the return statement must be the same as the type for the method. So if the method is of type integer, the return statement must return an integer. All arguments must have a type. So the parameters that are being sent must be of a particular type. The type must be the same as the type of the variable being sent. So let's have a look at an example. Supposing we had this in our program. We have a variable x of type string that contains the digits 293, and we have an integer variable y. Y is initialized by my method that takes in x. If my method is int my method string s, you can see that what's coming in string s is of the same type as what's being sent, string x. So that's fine. And what's returned is an integer. And since y is an integer, my method has to be an integer. And since my method is an integer, the return statement has to return an integer. And that's what we've got here. Matching these up can be a little complicated when you start, but you'll soon get the hang of that. So let's have a question. I'll give you a moment or two to look at this, and then you tell me which are the correct answers. Okay, ready? Let's get to work. It would work as it is. It has string y equals Fred, and strings are equivalent to arrays of characters. So what is being passed is equivalent in this case. String y is equivalent to char y. Also, what's being returned is the same. y.length is an integer, and it's looking to have an integer being returned to it. So this one would work. Therefore, it would not work, as it is incorrect. But would it work if y was char? If y was declared as char, as it is, that wouldn't work. But if it was array of char, as in do it, that would work. What about if x was float? Well, if x was float, that wouldn't work, because the type for the method and the type for the variable are different. Integer and float are not equivalent. String and char arrays are, but integer and float are not. And it can never work like this. Well, as we've seen, it does work, therefore it can work. Let's move on to the next area. Apply the static keyword to methods and fields. The keyword static can refer to a class, an integer, a method, or a variable. Static variables belong to a class and not an object. Therefore, you only have one copy of that variable. Normally, you'd have one copy for each object, but if it's declared as static, then there is only that one copy. You could use it to keep track of how many objects there are, for example. You wouldn't want that to change in each different object. Static methods cannot use object variables. So if we had a static method that's trying to access a variable in different objects, well, that wouldn't work. Non-static methods, however, can access static variables. So we could have an object having looked to see how many other objects of this type there are. Static classes and static interfaces are not in the exam. If it interests you, see the Mala Gupta book on page 54, where she'll give you an overview of what happens with these. Now a question about static. What, if anything, is incorrect about the declaration static void x? Again, I'll give you a minute to work it out. Okay, ready? Let's have a go. Well, let's see if the first one is correct. No, it's not. Not everything is fine. You see, the problem is that keyword static in front of int y. You can't use that sort of thing in a parameter. You can't tell it that it's static if you're trying to send a variable somewhere else, because it can't be static. A static method cannot be void. Yes, a static method can be void. So we could have static void x int y. That would make sense. The only problem is that keyword static in front of the int y. Parameters cannot be declared as static. Yes, that's true. Parameters cannot be declared as static. We've seen that already. X and y are of different types. Well, that's fine. We can have a method that has a different type to the parameters that it's using. Those don't have to match up at all. And this is remotely a Java construct. The only problem is that keyword static in the int y. So that is incorrect as well. The only correct answer is C. Parameters cannot be declared as static. Let's move on to 6.3. Create an overloaded method. A list of parameters passed to a method is called its signature. So you might have parameters being string and integer, the signature of that method is string and integer. Methods can have the same name as long as they have different signatures. So you can have several myMethod methods as long as their signatures are different. That's called overloading. This is useful when you want to perform the same task. For example, instantiating an object or sending information to print in several different ways. So overloading is used quite a lot. Now here's a question about overloading. Which do you think are correct? Again, I'll give you a minute to work it out. Okay, ready? Let's move on and have a look at the answers. The first one is incorrect. What we've got originally is float x string s. The type of the method has to be the same. So integer and float are not equivalent, so that fails there. Also, the signatures have to be different, and both have the signature of string s. So this first one fails on 2 counts. The type of the method is wrong, and the number of parameters passed and their type is wrong. The second one, however, is correct. That's of type float, x, but now the number of parameters is different. We could also have different types of parameters. So if we'd had integer, int s, that would have been classed as a different signature. So B is correct. C, float x string s, is incorrect because we can't have 2 methods with the same name and the same signature. In this case, it's the signature that's causing the problem. D, on the other hand, is correct. Unfortunately, string and char in this instance are not deemed to be equivalent. Strings are subtly different to char. So these would be different signatures and therefore allowed. Finally, this would not be allowed because of the type of the method. Our original method is float, this one is of type int, even though the signatures are different. So E fails as well. Now let's move on to 6.4. Differentiate between default and user-defined constructors. A constructor is a method which is used when a new object is created, and these can be overloaded, which is really useful when you have several different ways of getting that object into existence. All constructors in a class must have the same name as the class. So if the class is called Fred, all the constructors have to be called Fred, but they should have different signatures. If a programmer creates the constructor, then these are called user-defined, the user being the programmer who's using Java. It is not the user themselves. And Java initializes variables if no constructor is defined. So you'd usually use a constructor to set up the variables and make sure everything is laid out the way you want it to be. If you don't have a constructor, Java will set everything to its lowest common denominator. So integers will be set to 0, strings to empty, booleans to false, and so on. Let's have a look at a question. I'll give you a minute to work out which of the following are true. Ready? Let's move on. Let's see which of these are true. Users create user-defined constructors is a trick question. You'll remember that programmers create user-defined constructors. Users don't create anything. This is the sort of trick you can expect in the exam. There can be many constructors, all with the same name as the class, but they each have different signatures. A constructor must have a unique signature is obviously true. Variables are initialized by the default constructor. That is also true. If you don't define a constructor, the variables will be set to their lowest common denominator. Methods are initialized by the default constructor, though, is not true. You can't initialize a method. How can you initialize a task? So that one would be false. Let's move on to the next area. 6.5. Applying access modifiers. Access modifiers can be applied to methods and variables. There are three kinds of access modifier: public, protected, and private. Public methods or variables can be accessed by any other class, so it can be accessed from wherever. Whereas protected variables and methods are seen by the class and any of its subclasses, so it can't be seen from above or from outside. That is hidden. Private methods or variables can be accessed only from within that class, so they can't be accessed from outside at all. Variables and methods are deemed to be private by default, so if you don't declare something as being protected or public, it's assumed to be private. Local variables and parameters cannot use modifiers, so you can't have a parameter with a modifier or a local variable with a modifier. So if you had a loop that contained a variable declaration, you couldn't put private, public or protected in front of that. Let's try this question. Again, I'll give you a minute to work out the answer. Right, let's get cracking and see which ones are right. The first one, protected string Fred equals Fred, is correct. We're declaring something, a variable in this case called Fred, as being protected. It can be seen within this class and any of its subclasses. So they would all be able to see that Fred contains Fred. However, void doit public int OK is not correct because the parameters are not allowed to have access modifiers. So here, public int OK, it's the public being there that's the problem. Whereas here, public void doit int OK, that is correct because the declaration of the access modifier comes before the declaration of the type of method. The next one, protected boolean OK, is just a standard declaration, and yes, that's fine. You can have a variable called OK that's a boolean and can be seen within the class and by the classes below. But this one, E, is incorrect because the order is wrong. If it was protected int X, then that would be fine, but it isn't. So this one would be marked as incorrect. Now let's move on to 6.6, encapsulation. Encapsulation is really useful. It makes your code very much more bulletproof. A class that is thoroughly encapsulated will hide its variables and its main methods by making them all private. So it hides all its workings. To get at anything in that class, we use get and set methods that control the access so that the user cannot corrupt the data or see how things are done. You wouldn't want the user, for example, to put their name in the date of birth field. So what you'd have is a set method that checks that a date has really been entered. So you'd have set date of birth, and you'd want to make sure that what came in really was a date and not somebody's name or age or something. In that way, you can make sure that the user crashes your program far less often. Now, here's a question on encapsulation. I'll give you a minute to work out the answer. Right, your minute is up. Now let's see which of the following are incorrect about encapsulated classes. This is a trick question and is an example of the sort of thing you will come across in the exam. Notice that they're looking for the incorrect answers, so we tick those, not the ones that are right. So let's have a look at the first one. Do encapsulated classes have public variables? No, they don't. That is incorrect, so we tick it. Do they have public methods? No, that's incorrect as well, so we tick that one too. They use public get and set methods. That is correct, so we do not tick that one. They must have private methods is also correct, so we don't tick that. They must have protected methods. There may be some protected methods, but that's optional. That is not correct, therefore we tick it. Be careful of the wording of the questions in the exam. It's easy to get the logic the wrong way round. So let's move on to the final section. Determine the effect upon object references and primitive values when they're passed into methods that change the values. This sounds quite complicated, but as you'll see, it isn't really. Primitives, byte, short, integer, long, float, boolean, char and string, are not altered when passed as a parameter. So any parameters you pass in of these sorts will remain unchanged unless you alter them. The values within objects are changed when the object is passed as a parameter. So if you change the values of an object in a method, then those new values will be reflected in the old object. Let me show you this with an example. Here we have a program, albeit in 2 columns because it wouldn't go nicely on the screen. In here, the string name is going to be left unchanged, but di.name is altered because it's a class variable. So let me go through the code with you. We have 2 global variables being declared. A string name which contains Andy with a capital A, and an object of type doIt which is going to be used in a moment. Now let's have a look at doIt first. That down here just declares one variable called name which also contains Andy. So both the string name Andy and the doIt string name Andy are exactly the same. Now what we're going to do is pass these to 2 methods, uppercase it. In one case, and we're overloading here, in one case we're taking in name and in the other the object di. In both instances the task being performed is exactly the same. We're just converting what comes in to uppercase. However, the name variable will remain unchanged. All we're doing is changing the local variable n to be something different. But the name Andy isn't altered at all. It remains capital A, little ndy. However, in the second version here of uppercase it, we're passing an object, D. And here in D we're changing name to uppercase, but because it's an object, in this case name is being changed to uppercase. So what we get with the system out println is name, Andy, that's capital A, little ndy, some dots, and then Andy all in uppercase, because the primitives and the classes are handled differently. Now, your final question for this video. I'll give you a minute again. Okay, time's up. Let's move on. Again, we're looking for the incorrect answers, and since parameters can be primitives or objects, that is correct, and we don't tick it because we're looking for the incorrect ones. It's another one of those trick questions. Variables in objects can be changed. That's true. If we pass an object to a method, the variables within that object can be changed. So we don't tick that. However, variables in objects cannot be changed is incorrect. Therefore we tick it. Primitives are changed when passed is incorrect. Primitives are not changed when they're passed. And finally, primitives are unchanged when passed is true. Therefore we don't tick it. Be careful of the trick questions. You've got to get the logic right. Now then, further study for exam topic 6. This talk is just an introduction to exam topic 6. To do well in the exam, you need to study further. Go to the Moodle site for the course and find the links to the Oracle Java tutorial for working with methods and encapsulation. See the list of sections in the Mala Gupta book relevant to working with methods and encapsulation. And finally, post questions and help other students in the Working with Methods and Encapsulating forum. In that way, you'll make yourself far more ready for the exam, and then you'll do well.